I can fight monsters, I can't fight physics.
Ziad, thank you for these questions. So two wires, X and Y, have the same extension for the same load. X has a diameter D and is made of a metal of density rho, angle modulus C. Y has the same mass and length as X, but its diameter is 2D. So what are the density and angle modulus of the material of metal from which Y is made? Okay, so first of all, we know it's a Young modulus question. So E is equal to FL over A delta L. And they've told you the same extension, the same load for each wire. So same extension, so delta L, and the same load, F. These are both the same for both. So maybe we're going to use that later on. So, but they said density, so we got to somehow get density in there, and you've pretty much done it. You've worked out where to get density. So mass is rho v, and therefore mass is, and v is al, as you put down here. Not trying to steal your work, but so that rho al, and therefore, and we've got a in our formula. A is equal to m over rho L. So we could put that into our Young modulus formula, so which is what you've got here. So E is equal to, so because A is at the bottom, we're going to flip it. So rho L goes on the top, so F L rho L over, and then as you've got, M goes to the bottom with the delta L, so M delta L. So E is equal to F rho L squared over M delta L. So you got there, then for some reason you stopped. They said the same extension for the same load, so F and L are the same for both. So what the best thing to do is rearrange the formula for F over delta L. F over delta L is equal to, in this case, so the I'm going to take m to the other side, e m over, and then I'm going to take rho L squared. So rho L squared. So what we're now telling you, or what they're now saying to you is, E times m over rho L squared is the same for both. So what that means is, now I'll see if I can write this neatly, I doubt it. E x m x over rho x L x squared is equal to E y m y over rho y over L y squared. So what that means is, now they also said y has the same mass and same length, so the m's and the l's cancel. So what you're left with, I'm just going to go over to here, is that the Young modulus for x over the density of x is equal to the Young modulus for y over the density of y. So if we said that E over x, Ex over rho x is equal to 1, let's just say, that means what combination of density and Young modulus for y is going to give you that number 1. So if you look at these two, if you did Ey over rho y, Ey becomes E over 4 rho, and the 2 goes on the top, so 2 over 4, so that becomes a half. So you don't. So when you do E over rho for this, what do you get? E over 4, 4 goes to the bottom, 2 goes to the top, so you get half E over rho, which is not what you want. You want 1. So rho over 2, 4 over 2, 4e, so that becomes 4e at the top over times by 2 rho at the bottom, so that becomes 8. That becomes 8 E over rho, so that's no good. Well, E over 4, 4 goes to the bottom, rho over 4, 4 goes to the top, so they cancel, so that equals 1. So it's got to be C. Okay, hopefully that makes sense.